Surya-2 is one of the strongest open document OCR models of 2026, and unlike a plain text engine, it returns typed, structured blocks. So I ran it locally on my 8 gig laptop on the same 4 documents I use across this series and measured how it loads, how fast it is, how much memory it needs, and how good that structured output really is. The short version, it's excellent, but getting it running is not what you'd expect. Here's the document, a sample vendor invoice with a header, a bill to block, a line item table, and totals. Surya-2's whole design is about type structure. So the interesting question here is whether it labels these regions correctly. Is this a header? Is this a table? Is this a paragraph? It's the same invoice as every other model in the series. And here's the code. Surya-2, in this version, isn't a plain PyTorch model. It's a served vision language model that you run through the llama.cpp backend. You set 3 environment variables to point it at the Llama server binary and the GPU, then call the recognition predictor with full page true. It spins up the server, loads the GGUF, and returns typed blocks for the page. And this is Surya-2's real output, and it's genuinely different from a flat OCR engine. Every line is a type block, section header, text, or table, with its label right there. It correctly tagged the company name as a section header, the line items as a table, and the totals as text with 23, 21, 42 correct. That typing is what makes Surya useful downstream. You know not just the text, but what kind of region it came from. Here's the first surprise. Surya-2 in this version is not a plain pip install torch model that you just load and call. It's a served vision language model. It runs behind an inference server. The clean path on my machine was to run it through the llama.cpp backend, pointing it at the Llama server binary and the GPU with a few environment variables. Once that's wired up, you call a recognition predictor, and it returns the page. But if you expect a simple from pre-trained call, you'll be confused for a while. And there were real gotchas out of the box through a spawn error trying to launch a Docker-style server that wasn't there. The fix was explicitly selecting the llama.cpp backend and setting the torch device to CUDA. These aren't documented on the first page, and they're exactly the kind of thing that eats an afternoon. This is the recurring theme of local OCR. The model is capable, but the serving path is where the time goes. Once it's running, the speed is good. Warm, Surya-2 processed a page in around 13.5 seconds on my card. Not the fastest engine in the series, but perfectly usable for real document volumes, especially given what you get back. The first page is slower because it includes spinning up the server and loading the GGUF, so measure warm throughput, not the cold start, when you plan capacity. On memory, Surya-2 is well behaved. It sat at around 4.5 gigs of VRAM, leaving comfortable headroom on the 8 gig card. That's a real advantage over the 3 billion parameter models that crowd the top of the budget. You can run Surya-2 and still have room for other work on the same GPU, lean, fast enough, and structured. That combination is why it's become a default for a lot of document pipelines. And here's what makes Surya-2 special, the output. It doesn't return flat text. Every region comes back as a typed block. A section header, a paragraph, a table, each with its own HTML, its bounding box, and a confidence score. On the invoice, it correctly tagged the company name as a section header, the line items as a table, and the totals as text. That typing is what makes it useful downstream. You know not just what the text says, but what kind of region it came from and where it sits on the page. It also held up across document types, the 2-column article, the dense formula page, and a multilingual page with mixed scripts. Layout-aware models like this generalize across unseen formats far better than the old template-based OCR, which is exactly what you need when your documents don't all follow one house style. Reading order and structure survive, even when the page is messy. So the verdict, Surya-2 is a genuinely strong structured OCR model that runs comfortably on 8 gigs at 4.5 gigs and around 13 seconds a page, and returns type blocks with confidence scores that plug straight into a real pipeline. The only tax is the setup. It's a served model, and you have to wire up the backend, budget an afternoon for the environment, and after that it just works. The full breakdown is in the description. Surya-2, measured on my own 8 gig laptop, rather than README chart. If you want structured, layout-aware OCR that leaves room on the card, it's an excellent default. The exact backend fixes are in the description. I am Aditya. See you in the next one.